Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 1, that is differentiation, and our main topic is on the application of differentiation in economics. When we talk of economics, there are things to do with cost, revenue, and profit. So what do you mean by cost function? We are going to define each of them. So we define a cost function, or the simply total cost. Remember, total cost is equals to, let me write it. When we talk of total cost, which you are going to denote by C of X, I'll denote that by C as a function of X, C of X. This is equals to the variable cost plus the fixed cost. Now, fixed cost is a constant. An example, we can say e.g. C of X is equals to 3x squared minus 50 root x, that's 50 root x, then plus 2300. So the part that contain x, that is what you are calling the variable cost, the first part here, the one that depend on x, and this other part is the fixed cost. So our variable cost is this one, and this other one is the fixed cost, a constant. Now, what do you mean by x? Take note that what we are referring to as x, it simply means the quantity, or simply it is the total, or simply the quantity produced by the manufacturer. Quantity produced by the manufacturer. So that is called, we are going to refer to that as x. The C of x there stands for the cost function. So usually total cost is equal to variable cost plus fixed cost. When you talk of quantity produced, it's simply the number of units. You can talk of quantity produced or number of units produced. Is simply another term is number of units. Number of units produced by the manufacturer. Now, if you produce X units and you sell them, the amount you get after selling your X units, we refer to that as revenue. So number 2, we'll write here total revenue. Total revenue is simply equal to price per unit times the number of units produced and sold. So we are going to use the function R of X to mean that revenue function is equals to price per unit, which we are denoting by P, times, of course it is P, a function of X, then times X, where X is the number of units produced and sold. So if you have a relation, the function P of X, P that denotes price, P of X there, if you have this function, you take note that P, which is a function of X, that one, the P, the small p, to mean price, and you know X is the number of units produced and sold. This one here is called the demand function. Demand function. So to get the revenue, you multiply price per unit and the number of units produced and sold. We also have what we call profit. And what do you mean by profit? Number three, you write profit. Profit is given by total revenue minus total cost. And we are going to use the function P capital, now not small p. P capital, a function of X, is equals to R, a function of X, minus C, a function of X. Total revenue minus total cost. That will give us the profit earned by the company. Now, apart from the three, cost, revenue, and profit, we have what is called marginal cost, marginal revenue, and marginal profit. Let me talk about those three, I mean. Number four, marginal cost. The word margin, the marginal cost, what does it mean? It is the total cost, is the cost incurred in producing an extra unit given that X units have already been produced. So for example, let's say the company has produced 10 units of a commodity, and now you want to know how much will the company incur by producing the 11th unit. You have produced 10, you want to produce an extra one so that the total number of units produced will be 11. How much will you incur by producing that extra unit? That is what we are calling marginal cost. And in calculus, marginal cost is given by the formula. We'll denote that by MC to mean marginal cost. It is derivative of the cost function with respect to X. Very important. Also, we have another one, which is marginal revenue. What is it? This one is the revenue earned in producing and selling an extra unit of a commodity, given that X units have already been produced and sold. You want to know if you produce that extra unit and also sell it, how much will you earn on top, given that already you produced and sold X units? Just like the example of you have produced 10 units and you have sold them. Now you want to produce an extra unit, that is the 11th unit, and sell it also. How much will you earn as a result of producing that extra unit and also selling it? That is what you're calling marginal revenue. And in calculus, marginal revenue, which we are going to use denote by MR, is equals to derivative of the revenue function with respect to X. Another one is marginal profit. So that is number 6, marginal profit. Marginal profit, what does it mean? It is the profit. It is the profit gained by producing and selling an extra unit. That should be an extra unit, given that X units have already been produced and sold. So what profit will you get if you compare the marginal cost and the marginal revenue? You have produced and you know your marginal cost. You've also sold it and you know your marginal revenue. So what you gain on top is what you're calling the marginal profit. And in calculus, marginal profit is given by the formula. We are going to use MP to denote marginal profit. That is derivative of the profit function with respect to X. Apart from the marginal cost, marginal revenue, and marginal profit, we also have what you're calling average cost. Let's talk about average cost. That's number 7. Average cost. Now, when we talk of average cost, look at, let's say, for instance, you have produced 10 units of a commodity. You see, these units, you're going to sell them at different prices. Or you can even decide to sell them at the same price. But now you want to see what is the average. Let me explain that in a better way. You have produced 10 units of a commodity. Maybe the amount that you incurred in producing the first unit is different from the amount incurred in producing the second unit, etc. in that order. Now you want to see on average, I have produced 10 units. How much have I incurred on average? So you're going to add all the amounts that you incurred in producing each unit, then you divide by the number of units. That will give you the average cost. So this is simply equal to, we are going to use AC to stand for average cost is equals to the total cost. I can write this in full before I use the abbreviations. So this is always equals to total cost over number of units produced. So that simply means that average cost is equals to the total cost, which is C of X over X. So that is the formula. Total cost. In some books, you'll find them using CX bar. With the bar, it means average cost. In some books, you could find this. Take note that in some books, you'll find written as C of X, and this is bar. This is simply the same as average cost. So when you see the bar, just take note it's the same as average cost. Now, we also have average revenue. That's number 8. Average revenue. This is given by, now let me explain average revenue. It simply means that if you produced 10 units and you have sold them, you see each unit you're going to sell at different price. Maybe the first unit you sell at 100 shillings. The second unit, maybe you sell it at 110. The third unit you sell at 90. So you are selling these units at different prices. So having sold all the 10 units that you produced at those different prices, you want to know on average how much have I earned by selling the 10 units. You will add the amount that you earned by selling each unit, divide by the number of units that you produced and sold. So this given by the total revenue divided by number of units sold. And so we are saying mathematically that average revenue is simply equal to the revenue function divided by the number of units that you have sold. And in some books, you'll find them using R of X bar. So you take note, when you see R of X bar, this is the same as average revenue. And we also have number 9, average profit. On average is the same as mean. You want to know, by selling the first unit, what did I get as profit? By selling the second unit, what was the profit? So when you add all those profit, then you divide by the number of units that you produced, sold, that will give you average profit. So this is given by the profit function divided by number of units produced and sold. And so mathematically, we'll denote this by average profit. It is equals to the profit function divided by X. And in some books, you'll find them using P of X bar. So you can now take note that P of X bar is the same as average profit. Average profit. Now, apart from those 9 items that we have looked at, and I have given you the formula in each of them, when we are studying economics, the aim is to maximize the profit while minimizing the cost. You maximize profit. You also need to maximize your revenue, but you need to minimize cost. That is the aim in economics. So then the question is, how do you apply your knowledge of mathematics to be able to maximize profit, to be able to minimize costs, and also to be able to maximize the revenue? This is what you do. So you can write, we take note that the aim in economics, you can just say that should be in economics, comma, the aim is to maximize revenue and profit while minimizing cost. That is the aim in economics. So then, how do you maximize profit? How do you maximize revenue? How do you minimize cost? So you can write this, that at maximum revenue, we know that derivative of r with respect to x must be equal to 0. When you want to know whether you're going to maximize your revenue, you must first of all differentiate revenue function with respect to x and equate it to 0. So when you solve it, you solve this equation to get x. And this x is what you are calling the revenue maximizing level of production. The revenue maximizing level of production. That x that you're going to get. And you know, you don't just assume that the value of x will give you the maximum revenue. You must test using the second derivative test. You must know that it is not always the case that the x that you have found should always give you the maximum revenue. So use second derivative test. So okay, if d squared r dx squared at that value of x that you have found, if the result is less than 0, if the result is less than 0, then it means that that value of x is the revenue maximizing level of production. So that will mean that the value of x that you have found will give you the maximum revenue. That is what will lead you to that. So you must test, don't assume. Let's also see, how do we maximize profit? This was part A. Part B, at maximum profit, what we require is that derivative of the profit function with respect to x must be equal to 0. This will be an equation, whichever equation that you need to solve to get x. So you need to solve to get the value of x. That value of X will be the profit. That is the profit maximizing level of production. And for you to know that it is the profit maximizing level of production, you must test whether this one, if d squared p dx squared is a value less than 0. If that is the case, then it means that the value of X that you have found will lead to, or will give you, the maximum profit. Another one is, how do you minimize cost? So, but see, we can talk of at minimum cost. What do we know? To minimize cost, again, you require that derivative of the cost function with respect to X must be equal to 0. That's what we know. So you need to solve this equation. Solve to get the value of X, which is the cost minimizing level of production. Cost minimizing level of production. And you must also use second derivative test to know whether truly whether the value of X that you have found will give you the minimum cost. So you must test whether d squared c with respect to X is a value. Now for minimum, the value must be greater than 0. Very important. If that is true, then it means that that value that you have found will give you the minimum cost possible. So do not deviate from the aim when you are dealing with economic models or problems. Apart from what I have talked about so far, we need to take note of some two terms here, which are usually used in economics. And the first term is this one. So you can write a note, NB. Note number one is what you are calling the break-even point. What do you mean by the break-even point? It is the point where the total cost, is equals to total revenue. So it is the value of X that will satisfy that equation. So we are saying C of X is equals to R of X. This will be an equation that you need to solve to get X. That X that you're getting is what you're calling the break-even point. So you solve to get X. So when we say total cost is equals to total revenue, it simply means that this break-even point is that point where once you have produced units of some commodity, you want to know how many of those units will I sell to recover the amount that you used in production. That is what we mean by break-even point. How many do I need to sell for me to recover the amount that I used in production, so that anything that you sell on top of the break-even point will give you profit. So I hope that is understood. Another term here is what you are calling the point of diminishing returns. Let me write it. Point of diminishing returns. What do you mean by this? It is simply the point where the second derivative of the profit function with respect to x is equals to 0. That is what you call the point of diminishing returns. So you're going to differentiate the profit function twice, equate it to 0, and solve for x. The value of x you get there will tell you that that is the point of diminishing returns. So having explained all those terminologies in economics, let us look at an example of a problem in economics. So I'll write here example. I'll just summarize the question. You are told that in marketing a certain commodity, a business has discovered that the demand for the commodity is represented by, so I'm just going to give you what is written. The demand is represented by P of X is equals to, remember the P small to mean price, 50 over root X. This is the demand function. We are also told that the cost of producing X units of the commodity is given by, so again we are told the cost is given by C of X is equals to 0.5x plus 500. We are asked to find the following. Remember, this is total cost. Total cost. So the task is find the revenue and the profit functions that's not Roman 1. Roman 2, we need to find the price per unit that will give maximum profit. Price per unit that will yield maximum profit. You also need to find break-even point, and the point of diminishing returns. So we need to find the price per unit that will yield the maximum profit, etc. So let's work out this problem. First of all, we need to know what is the revenue and profit. So you can write here solution. Solution. We know that revenue function R of X is equals to the profit, the price or price per unit, that's P of X, times the number of units produced, that is X. So this is equals to price per unit is 50 over root X times X. 50 over root X times X, of which this is the same as 50 times X over root X. X over root X, when you apply the laws of indices, you are going to get 50. Remember, it is 50 times X over root X is the same as X raised to 1 over 2, of which if I simplify this one, I'm going to get 50 times X raised to 1 over 2, laws of indices. When you're dividing, you need to subtract those powers. Or you can also write this as 50 root X. That is our revenue function. Let me write this as 50 root X. 50 times root X. Our revenue. What about the profit? Remember, we are answering part one. Part one of the question. The profit, P capital, as a function of X, it is equals to, this is a function of X, that should be equal to the revenue minus the cost. And what will it be equal to? Take our revenue, which is 50 root X, minus our cost function is 0.5x plus 500. When I subtract, I'm going to get the profit as 50 root X minus 0.5 X minus 500. That is our profit function. Now, that is the first part. Second part, we need to find price per unit that will yield maximum profit. So as long as we are talking of maximizing the profit, we must get the first derivative of profit function with respect to X. So get dP dx, differentiate the profit function. That will give us, when you differentiate root X, you get 1 over 2 root X. So it is 50 times 1 over 2 root X. I've used power rule. Remember, root X is the same as X raised to 1 over 2. So when you use the power rule of differentiation, when you're differentiating X raised to power N, in this case, our N is 1 over 2. You're going to get that. Then minus, when you differentiate 0.5x, you get 0.5. This can be simplified to give us 25 over root X minus 0.5. Now, we said this dP dx must be equal to 0 so that we can be able to find the profit maximizing level of production. So equate this to 0. So we are saying, therefore, 25 over root x minus 0.5 should be equal to 0. So we need to solve for x. Solve for x. So this means 25 over root x is equals to 0.5, of which we can write this as 25 over 0.5 is equals to root x. 0.5 is the same as 1 over 2. So you can now be able to find x from there. So 25 over 0.5, that is 50, because 0.5 is 1 over 2. So we can say, or let me use another color, or root x is equals to 50. So you square both sides to get x. So in this case, root x squared will give us x is equals to 50 squared, which is 2500. And these are units. X is 2500. But I told you we are not sure whether the value of x that we have found will give us the maximum profit. So we have to test so that we are sure. We need to use second derivative test. So using second derivative test, use second derivative test. Why are we using the second derivative test? Because we need to know whether the value of x that we have found will yield maximum profit. So I'll find the second derivative of the profit function with respect to x. So d squared p dx squared. Differentiate the first derivative. Look at what you are differentiating, the one I have ticked. With respect to x, when you differentiate 1 over root x, remember 1 over root x is the same as x raised to negative 1 over 2. So it will be a derivative with respect to x of 25 times x raised to negative 1 over 2 minus 0.5. We are just differentiating the answer we got in the first derivative. So what will be the answer here? When you use power rule to differentiate x raised to negative 1 over 2. So that will give us 25 times negative 1 over 2, then x raised to negative 1 over 2 minus 1 will give you negative 3 over 2. Now, when x is 2500, what will be? Remember, this can be written as, before I substitute x, negative 25 over 2 root x cubed. That's how it can be written, so that you can easily see the way it is explicitly. Now, when you substitute x is equals to, we put x is equals to 2500. What are we going to get? It will be negative 25 divided by 2 times the root of 2500, and this is supposed to be cubed. So what is the answer here? The square root of 2500, that is 50. So you take 50 cubed. It is clear that this answer will be a number that is negative, and so a negative number is less than 0. So this value here is less than, because we are just interested on the sign. Is it greater? No, this is not greater, this is less. So let me change. less than is this sign, less than 0. So because it's less than 0, what does it mean? It simply means that the value of x that you got will give you the maximum profit. So this means maximum. So therefore, the profit, maximizing level of production is x is equals to 2500 units. When you produce 2500 units for this particular company or manufacturer, then for you to maximize the profit, you have to produce those 2500 units. Now we want to know the price per unit. So price per unit is equals to the small p when x is 2500. So this will be, it was 50 over root x over the square root of 2500. And so that is 50 over 50, which is 1. So let's say it was in dollars. So that means the price per unit should be $1 for you to maximize the profit. And in the other part, we are asked to find, in part 3, we are asked to find the break-even point. Break-even point. So what do we know about this point? We said that at any break-even point, the total cost must be equal to the total revenue. So look at our revenue function, that was 50 root x. Equate that to the cost function 0.5x plus 500, and then solve for x. So that means 50, let me use another color. Before I write 50 root x, it means the revenue must be equal to the cost. So our revenue was 50 root x. This must be equal to our cost. We are given that as 0.5x plus 500. We need to solve for x. 50 root x is equals to 0.5x plus 500. This is a radical equation. So what we are going to do here is to square both sides so that I get rid of the square root. So, or I said this is a radical equation. Radical, so get rid of the square root. So we'll have 50 root x squared. This should be equal to 0.5x plus 500 squared. I'm just solving for x. So this means when you square 50, you get 2500. X is equals to, remember a plus b squared is a squared, that is 0.5 x squared, 0.5 squared, which is 0.25 x squared plus 0.5x times 500, that will give us plus 500x then plus 500 squared. 500 squared is 25. Let me create another space here so that I write it along the same line. So this is 25 with the 4 zeros. That is when you square 500. So we need to simplify the equation. Let us take everything to the left hand side, to the right hand side. So you can just say or 0.25 x squared. Then there we'll have 500 x minus 2500. So what is that? 500 minus 2500. That will give us minus 2000x. Then I can see there's plus 25 with the 4 zeros. And this is supposed to be equal to 0. Let me make the coefficient of x squared to be 1. So I'm going to divide the entire equation by 0.25. This is a quadratic equation. So you can just say, or what I'm going to do here is to divide that equation through by 0.25. So we are going to get x squared minus, let's take 2000 divided by 0.25. That will give us 8,000. 8,000 x plus, now we have 25 with the 4 zeros. We are dividing by 0.25. That will give us 1 million. 1 million is equals to 0. So let's solve this equation using quadratic formula. So we say x is equals to negative of b, that is 800, no, that's 8,000, plus or minus the square root of b squared. What is 8,000 squared? So that is 64 with the, how many zeros? The 6 zeros. Then minus, remember the formula, negative b plus or minus b squared minus 4 times a times c. Our a is 1, c is 1 million. So that will give us 4 million. Everything you divide by 2 times a, and our a is 1. The formula is x is equals to negative b plus or minus the square root of b squared minus 4ac, everything over 2a. That's what I've used. So 64 million minus 4 million, that will give us 60 million. So that is root of 60 million, the square root of 60 million. Let's see. Of course, the result will be a decimal. Let me round up to the nearest, because this x means the number of units produced. So we can round up that to the nearest whole number. So this is the same as, this equals to, I can pick another color. The root of 60 million is 7,745.967. so that this we can now write as 8,000 plus or minus 777, that's 77, not 79, 7745.9, so that is 46. 46 divided by 2. And you see x cannot be negative. So let's start with the positive part. 8,000 plus 7746 divided by 2. What are we going to get? So you can write this. So we'll say, let me delete this equal sign that I've written. From what we have found here, we can just say therefore, x is equals to, just press in your calculator. I have 8,000 plus 7746. Then you divide by 2. That will give you 7873. Another value of x when we use negative, so we'll have 8,000 minus 7746. The answer you divide by 2, you're going to get 127. 127. So what does it tell you? That this company, for it to break even, it must produce either 127 and sell them units, or it must also produce 7,873 units and sell them for the manufacturer to recover the amount incurred in the production. Another one is the point of diminishing returns. Let me just bracket this to make these two are the break-even points. And I already told you what you mean by break-even point. Now, point of diminishing returns is where the second derivative of the profit function is equals to 0. And then solve for x. Look at our second derivative of the profit function. This is what we got. Let me circle it. You see what we got? This one. So that is what you're going to equate to 0 and then solve for x. It was not that. The one without, before we substitute for x. Which one was it? It is this. This is what I'm interested in. Before you substitute for x. So that's negative 25 over 2 root x cubed. We equate that to 0 to get the point of diminishing returns. So I'm going to write here. Another one is point of diminishing returns. What do we know about this point is that d squared p dx squared, that is supposed to be equal to 0. We know d squared p, we got that as negative 25 over 2 root x cubed. That's what we got. This equals to 0. Can we be able to find the value of x here? No. This equation, you cannot solve it for x because the x is in the denominator. That x is in the denominator. You see, this equation is the same as writing, let me explain to you, that it is the same as writing 2 times root x, and this is cubed, over negative 25 is equals to 1 over 0. What have I done? I have taken the reciprocal on both sides of this equation. You see, you cannot find, because 1 over 0 is infinity. 1 over 0 is infinity. So this one here is infinity. So it means even if I were to solve for x, I am going to get x is equals to infinity. X is equals to infinity. And you see, infinity is not a real number. So what does it mean? That there is no point of diminishing returns, because we are finding x to be infinity, which is not a real number. So no point of diminishing returns. So having explained all those, I want to believe now when you are given any question in economics and you are asked to apply your knowledge of calculus, you should be able to tackle it, whichever question that you are given. As long as you can be able to find the cost function, the revenue function, and the profit function, those three functions are enough for you to answer any question in economics. And in this problem, let's say you are asked to find the fixed cost. Look at our cost function, and I told you fixed cost is the constant term. Look at the constant term in our cost function. If you're asked to find the fixed cost, then it is this value. It is positive 500. That is the fixed cost. It can never be negative. If it is negative, then there's something wrong. And the other part is the variable cost. Variable cost is 0.5x, and the fixed cost is 500. What we are calling the overhead cost, whichever. So thank you all for watching this video. Please subscribe to my YouTube channel. That is Professor Francis Okech. When you go to the YouTube search, please type Francis Okech, and you will find me right there. Also, don't forget to comment, to share, and also to like this video. Next time when we meet, we look at other applications of calculus, or simply differential calculus. We simply want to look at how to apply differentiation in real life situation. Let's meet next time. Bye bye.